Hello everyone. My name is Danielle Aregi, and I'm a Senior Developer Advocate, Data Cloud Developer Advocate on the Developer Relations team, and welcome to Data Cloud for Developers. And with me, I have
Aditya, also a Developer Advocate on Daniel's team.
And you can follow me on Twitter. You can also follow me on LinkedIn as well.
And you can follow me on LinkedIn. We left Twitter some time ago.
Okay, so just going to start with our forward-looking statement. Please make all your purchasing decisions based off of what is available in the system today and not off of any new product enhancements or features that we say may be coming to the platform or any of our products that we're speaking about today. So just want to give a very, very warm thank you to all of you for coming to this session. I know there's a lot of other great sessions that are happening at this exact same time, so we really, really appreciate you being here today. And we are going to go ahead and jump right into our presentation. So what is Data Cloud and how does it work? Has anyone here already worked with Data Cloud or played around on Trailhead with Data Cloud? Awesome, amazing. So Data Cloud is a system that allows you to ingest data from multiple connected source systems. Data Cloud has multiple connectors. We have a Salesforce CRM connector, which allows you to pull in data from Service Cloud, Sales Cloud. We also have a Marketing Cloud connector, which allows you to pull in any type of data about subscribers or data stored in data extensions within Marketing Cloud. We have a Commerce Cloud connector as well. We also have connectors to Amazon S3, Google Cloud Storage, as well as Microsoft Azure, which allows you to pull in data from a CSV file. And new, which we will be talking about in this presentation a little bit more, is we have the ability to bring over data from both Snowflake and Google BigQuery using our new Bring Your Own Lake functionality, which requires 0 ETL, so no ETL for pulling over data. We also have multiple SDKs. We have a mobile SDK, which allows you to pull in data from iOS and Android apps. We have a web SDK, which allows you to pull in data from your custom developed websites. And all of this data that's coming in should always be about a customer, because Data Cloud is a customer data platform, okay? We also have the ability to pull in data from MuleSoft, so anything that any point can connect to, you can pull in data from Workday, SQL databases, NoSQL databases, SAP even. All of that data can flow through to Data Cloud's data lake via MuleSoft. And speaking of our data lake, we have two types of objects. We have data lake objects and data model objects, and all of that resides into one harmonized canonical data model within Data Cloud. From there, you have the ability to build data graphs. You have the ability to combine multiple source profiles using identity resolution into unified profiles. And this is all to build a single source of truth about your customer, so that then you can start doing things like activations with your data. You can build calculated insights, which we're going to show you in the presentation today. You can build segments so that you can put people into Marketing Cloud journeys and send emails and text messages. You can also build Facebook and Amazon ad audiences and Google ad audiences so that you can start acting on your data within our data lake. We have several Tableau connectors, and we even have the ability to build AI on top of all of this as well. So you have the ability to connect an AI model, such as a Vertex AI model, a SageMaker AI model, and newly you also have the ability to connect an AI model from Databricks as well. Okay. So speaking of data ingestion, so you'll remember that I spoke about these data lake objects, right, that reside within our data lake. So after you make a connection to a source system, such as Marketing Cloud or SAP or Workday, what happens is all of that data that comes in via a data stream that you create, okay? So you create the connection to the source system, then you create the data stream, and all of the data from that source system flows into that data stream into a data lake object. Now your data lake object is your initial container that's going to hold the data. There's no transformation or anything at this point. All of the data is just coming in and initially hitting our data lake, and it's hitting our data lake object, okay? Now with MuleSoft, again, you have the ability to use our MuleSoft connector, right, to pull in data, once again, from SAP, from Workday, using the Ingestion API. So let's say we don't have an out-of-the-box connector. right? We don't have a connector for the system that you want to pull in data from natively right now, or we don't have a BYOL, or bring your own lake, right? Connection right now. You have the ability to use MuleSoft and our Ingestion API to pull in data from any of the source systems that MuleSoft has the ability to connect to at any point. We do not currently support MuleSoft Composer, so sorry for those Salesforce admins that might be out in the audience or those people that are using MuleSoft Composer. Right now, we don't support Composer and whatever Composer can connect to, but any of the connectors that any point can connect to, we can bring in data from those connectors. Okay. So after all of this data hits initially our data lake object, what we then have the ability to do is start mapping our data that resides in our data lake object to something called a data model object. Now, who here has worked with Salesforce? It should be everybody in the room. Awesome. So in Salesforce, you're familiar with standard and custom objects, right? You have your standard objects, your account, your contact, your lead, your opportunity, your case, and then whatever custom objects you've created in your Salesforce instance. Well, in Data Cloud, we actually have something called data lake objects and data model objects. And the data lake, remember, the data lake objects are your initial containers that your data streams are putting all that data from your first connected source systems into. Well, we need to map that data to something that Data Cloud understands. Data Cloud's metadata, basically, is metadata structure. So Data Cloud's metadata structure, or canonical data model, is the data model objects, all right? So all that data comes in, and then you have to map it to Data Cloud's data model objects, something that Data Cloud understands and knows what it is, okay? So we have a variety of standard data model objects that you can map to. We have some of the ones that you're more familiar with, so account, contact, and lead. You'll always know whether you're in a data lake object, because a data lake object will have underscore DLL versus a data model object will have underscore DLM. So you'll know the difference between the two. But you also have the ability to create custom data model objects to map to. So if you're bringing in some custom data that doesn't match exactly one of our out-of-the-box data model objects, you have the ability to create your own custom data model objects, and you also have the ability to create your own fields on standard and custom data model objects using our field typings. Now right now, some of our field typings are a little bit limited, but I already saw on the roadmap that they're gonna be bringing in lots more field types so that you can start mapping pick lists and Boolean values and things like that in your data models. Okay. Now, so traditionally, you always had to use one of our connectors and copy the data over from your source system. So when you were connecting to Marketing Cloud, Salesforce CRM, Workday, or some other system, the data was always coming in from the data stream and always being copied physically into our data lake. But as of recently, we've been working on the ability to do a data share, which we consider our bring your own lake capability, which allows you to create virtual tables and virtual external data lake objects and data model objects within Data Cloud, which allows you to no longer have to actually copy all the data over from a Snowflake or from a Google BigQuery, but it allows you to use your Data Cloud functionality on existing data lakes like BigQuery and Snowflake without actually extracting, transforming, and loading the data into Data Cloud's data lake. So some people are like, I don't want to go through the trouble of loading the data, mapping the data, and all of that. You don't have to do that anymore with our new Bring Your Own Lake functionality. So one of the new ones that we have coming out as of this month is the ability to bring your own lake using Google BigQuery. And we also have an integration with Snowflake as well. So you have the ability to copy over your data, sorry, not copy over, but you have the ability to share your data from Snowflake's data lake over to Data Cloud and use Data Cloud's functionality on your Snowflake data lake without having to actually load it into Data Cloud. So right now, what's GA is the ability to share your Salesforce Data Cloud data to Snowflake. That part is GA. So you can just do a data share, which then makes your Salesforce Data Cloud data lake objects and data model objects available in Snowflake to be able to use Snowflake's functionality on top of your Data Cloud data. And going GA, maybe later this month, is the ability to share your Snowflake data back to Data Cloud without having to actually extract, transform, and load it into Data Cloud. So here's a little bit of the implementation details of how it works, of going from Salesforce Data Cloud to Snowflake. We do have Salesforce Data Cloud developer environments are now available on Trailhead, and I've heard that Snowflake also has developer environments, so if you want to test this out, you can. But here are some of the implementation details of how you create that data share and how the data share is actually working to share your Salesforce Data Cloud data lake data model object to Snowflake. And here's the implementation details of how it works the other way, because I used to get a lot of questions about the bidirectional of it coming back from Snowflake into Data Cloud. So here are more of the implementation details of how that is exactly happening from Snowflake back into Data Cloud. Okay. Some phones. Okay. So now what I'm going to do is I'm going to do a demo of our Ingestion API. So here we are in Data Cloud, and you'll say, for some people that might not have ever seen Data Cloud before, you might say, this looks a lot like Salesforce. Well, Data Cloud is accessed in your Salesforce Hub org. So you'll have a Salesforce Hub org that will have Data Cloud turned on, and you access it in your app launcher like you would access any other app, like your service app or your sales app or any other custom app that you've created. Now I get a lot of questions, does that mean that my Salesforce data is shared to my Data Cloud data lake and my Data Cloud data lake is shared automatically to Salesforce? No, they are not. You actually have to go into Data Cloud setup, and you actually have to go here to Salesforce CRM, and you have to create the connection between either the Hub org that's hosting your Salesforce Data Cloud instance or some other Salesforce org. And then that makes the data in your Salesforce CRM, all your objects, your standard objects and your custom objects accessible from Salesforce Data Cloud. And you can see here, you can connect to other production orgs, and you can also connect to sandbox orgs. So we have our customer here, or our sample fictitious customer. They're called Solar Circles. You might have seen them if you've been to a few of our events. And Solar Circles sells solar panels. And they've created a few APIs already that they are ingesting via the Ingestion API. So here you can see all the Ingestion APIs that they've already set up. Now here you have to load your files in OAS format. You'll come here and create, you'll come here, you'll create the connector, and then after you create the connector, you'll have to upload a schema, and the schema needs to be in OAS format. I'm not going to create a new connector here, but you'll see here two of the objects that I'm already ingesting from my source system that's connected, that's feeding me solar panel events into my Data Cloud org. I'm going to show you our schemas here. So here we have two of our schemas that we've already uploaded, our performance summary schema, as well as the different fields and field types. And what I'm going to do is I'm going to use Postman to simulate Data Cloud ingesting a performance summary event from a source system. So here we have our endpoint that we are going to be inserting records in via our Ingestion API. And I'm just going to change this in front of you. So here's our body. I don't know why I'm doing that. So here's our body. And I'm just going to change this number to 4. And then I'm going to send this to our endpoint. And what this has simulated is us putting in a record into our data stream in Salesforce Data Cloud. So now what I'm going to do is I'm going to go here into data streams. And remember, data streams are how you get data into Data Cloud. So we have multiple data streams to pull in data. We have our Salesforce CRM data stream to get in those accounts, those contacts, those opportunities. We also have the S3 data stream to get in data from CSV and so on. And I'm going to go here to my solar panel events performance summary data stream. And you can see here is my data lake object where all of those solar panel performance summary events are hitting. And you can see here are all of the fields that got created as a result of me uploading my schema. And now, since I have fired off that event using Postman, simulating, simulating a new record coming into Data Cloud from my API, that will be inserted into Data Cloud's data lake. And I've already mapped my data lake object to my data model object, so that record will also be inserted into my mapped data model objects as well. Okay? So now, what we are going to do is We've talked to you about how to get data into Data Cloud. Now what we're going to do is talk to you about all of the things you can do after you've ingested your data into Data Cloud. And Aditya is going to take it from here.
All right, thanks, Daniel. So like Daniel mentioned, you've gotten a lot of data from all the different systems into Data Cloud. And we get a lot of questions saying, OK, this is something that many other tools can do, so what's so special about Data Cloud? So what's so special about Data Cloud is everything in the Activate section. So getting data in is not a problem, but once the data is in, what can you do with it is the possibilities that Data Cloud gives you. Out of that, the first possibility that Data Cloud offers you is calculated insights. Now, what are calculated insights? You have all of this bunch of data that is sitting in your data lake objects, data model objects. Now, you need to start making sense of all of that data. And that's what insights let you do. To put it in a very simple manner, how many of you have worked with aggregate queries before? Most of you, right? So you think of this as a supercharged aggregate query. Right? So you can create a lot of metrics. You write statements, which is what I'm going to show you. But the important thing is you can create two kinds of insights. One is a calculated insight, and the other one is a streaming insight. So calculated insights are written on bulk data. You have a bunch of data sitting in your database. You want to get insights out of it, like how many records are there, how many people fall into this bucket, this bucket, this bucket. You can do that. On the other hand, we have streaming insights that let you actually take real-time action on data. So in our use case, we are dealing with solar circles, which is going to sell solar panels. And using Ingestion API, what we are doing is we are capturing the voltage levels of the solar panel every second. Now, what streaming insights let you do is create a metric that says, what is the average voltage in this 10-minute window? So as and when the data is coming in, a streaming insight will calculate that data on the fly and give you an average voltage. And what you can do with that average voltage? You can write your business logic on it, saying, let's say if the average voltage peaks, then maybe raise a case, or there is something wrong with the panel. So that's the level of proactive action you'll be able to take with streaming insights. Now, you can create insights using a SQL query or a drag and drop builder. Now, it's important to remember that I mentioned a SQL query, not a SOQL query, because we are dealing with data lake objects. Data lake houses massive amounts of data, and SOQL is really optimized towards your transactional data in Salesforce, which is your accounts, contacts, data that changes frequently. But data lake stores all of your long-term data, engagement data. So traditional SQL statements is the way to go. Now, let's actually look at a demo on how you can do all of this. OK, so where were we? We were here. So one of the tabs in Data Cloud is going to be your calculated insights, which is going to show you all the different insights you've already created. Now, here is an insight I created for the total power consumption. So I'm getting all the events from the solar panel, so I have all of the data sitting in. What I simply want to do is create a leaderboard to say which of my customers is consuming the maximum amount of power. So that's a simple use case that I have. So what I can do is I can create this expression. It's very long because the API names are that long. So like you have solar panel performance summary underscore underscore DLM. So it's a basic SQL query where you're selecting and you're aggregating because we have the sum function. Then because it's SQL, you can do inner joins, outer joins as well. So there are joins in the SQL statement. There are group bys. So which is why I said this is like a supercharged aggregate query. Now, if you're not somebody who's learned SQL like me, because SQL is something that I learned when I was in college but never used it afterwards because Salesforce doesn't use SQL, I kind of lost touch with it. Now, if that is the case, we also offer a builder that's going to look like this. So essentially what I've done, it looks like a flow. These are all your different objects, and you can join them using this join element. And within that, you have your left join, right join. Once it loads, you'll be able to see it, but it's there. And after that, after you join all your tables, you can aggregate on them. This is taking surprisingly long, but it's fine. You're able to see, right, through the blurred screen. So I can aggregate it using measures and dimensions, and all of this is technical terminology. Essentially, measures means your sum, Dimensions means group by. So that's all. It's the same. So you'll be able to create something like this. Now, once you create this calculated insight, it's going to run automatically in the background. And you can see what it does by going to the Data Explorer. So if we want to see data from Salesforce, we typically write a SQL query in Developer Console or VS Code, or we create a list view. But within Data Cloud, what you can do is go to the Data Explorer, where you can select any object that you want. If you want to see what data is there in your data lake object, you'll be able to do that. Similarly, I created a calculated insight, which is also kind of stored in an object kind of representation because it's aggregated data. So you select your calculated insight, and which is exactly what is going to show up. Because I've summed up all the total power consumed, it's going to show me this. I've grouped it by the contact ID, so the contact IDs are present here. So this is a table that I was able to create using a calculated insight. Now let's take a streaming insight example. I was talking to you about voltage drops in 10 minutes. Now, your streaming insight is going to look exactly the same. It's again a SQL statement that you write, but there is going to be one change. So within your group by clause, you're going to have the statement window. So the window is what defines during what period of time you're trying to aggregate your data. So for this use case, I've given 10 minutes. You can go up to 2 hours. Is the maximum interval that we support. And once you create this, again, the data is going to be created. There's going to be a table that forms. Now, this step is fine. I mean, you've created your insight. You've created a new table. But still, the data is there in Data Cloud. You're not really putting it to action. So where can you put it to action? Is this really cool feature that we launched in the last release, which is what we are calling enrichments. So this is a traditional contact record, nothing very fancy here. And we have a field on the contact record called total power consumed. This is on the Salesforce contact object. Right now, what I can do is the value of this field can be pulled in from Data Cloud. So a calculated insight runs in Data Cloud, pushes that value back into your CRM records. You might think it takes a lot of integration, but it's actually built right into your setup. So this is the object manager for the contact, along with all the different things that you're used to, like page layouts, details. There's a new thing called Data Cloud Copy Field. What it lets you do is simply select where you want to copy the data from, which is our total power consumption calculated insight. And we are putting it into the contact object's total power consumed field. And this data is synced regularly, and you can also see the sync history on when the last sync has happened, and the data is going to be pulled in. So that's one way you can pull all of this data in. So that is what I nicely summarized in this slide, which you can all take a picture of. Along with copying the fields, what you can also do is copy related lists. So like all of the data that you're storing can be shown as a related list on a particular contact or a lead record. So both of these are available right now out of the box. Now, once your data is sitting in Data Cloud, you can query that data. Like proactively, whenever you want, let's say you are showing a Lightning Web Component, you want to query some data, you'll be able to do that. And there are multiple ways in which you can query data. One is flows. So within flows, all of us have worked with a get record element before, and that always used to let us only select Salesforce objects. But now you can also choose Data Cloud objects. You're going to see a nice little radio button, which lets you choose between a Salesforce object and Data Cloud object, query the data you want. This is Data Cloud for Developers session, so we're going to look at Apex and see how you can query data using Apex. And of course, as you know, Salesforce is API first. Anything that you can do with Apex, you can do with APIs as well. So here I have a use case of the leaderboard that I was talking about. I created a calculated insight, and I want to show this Lightning Web Component that shows me who are my top 5 power consumers. So it's a Lightning Web Component, which is going to use Apex in the background. And this is the Apex code for that particular data controller. Let me zoom it in. So what you can see here is a connect API method, that lets you query calculated insights. So we are surfacing all of Data Cloud APIs and endpoints through the Connect API. So just hit this method and send in the required details, like what is the name of the calculated insight. But that's not all. You have a big table sitting in, so you'll be able to filter that out as well. So you can specify filters. Let's say I want to order the table in the descending order, I can do that. So you can do a lot more when you're trying to query data from a calculated insight. So that's something I've done. Then there is a bunch of logic that I've written that is relevant to my Lightning Web component, which you can do and return the data from there. So this is your traditional Apex. Now, not just calculated insights, but you can actually run a SQL statement directly on your data lake objects and data model objects. Again, using Connect API. So you have a method called query ANSI SQL. Use that method, write in a SQL statement, and you're going to get the data back. But if you're somebody who wants to write a traditional SQL statement, you can still do that. So this is your database.query. And here I'm querying the, this has been zoomed in, so I'm querying the individual object. So SQL is more relevant when your data is harmonized and you're trying to deal with data model objects, but not really relevant when you're directly trying to query your data lake objects. So there are a few considerations, like in this SQL you can't do group by and stuff. So it's a traditional simple query that you can write. So that is a small peek into how you can access Data Cloud data from your Apex classes. But there is another side of it. Data is not always pulled. Sometimes you want data pushed to you. Like if something is happening in Data Cloud, you want to know about it. That's where in Apex you have triggers. Very similarly, in Data Cloud, you can create what we call a Data Cloud triggered flow. So if changes happen in Data Cloud, this flow gets executed. As simple as that. But when it comes to Apex, what you can do really is first create a data action. Now that I can show it to you in a demo. So within Data Cloud, you have a new tab called Data Action, and what it lets you do is fire a platform event whenever changes happen in Data Cloud data. Now this is a more scalable way of doing things instead of writing a trigger, which is why traditionally we disallow triggers on data lake objects because of the massive scale. If you want to react to changes, fire platform events, and platform events is something that is scalable. And when you're firing these platform events, you can define event rules, like a traditional trigger whenever a record is created or updated, and you can also give in conditions. So here the exact condition is, if the number of voltage drops is greater than 3, I want to fire a platform event. So this is based on the calculated insight I created. Now I do this, it fires a platform event that is taken care by the platform, and you might want to subscribe to that platform event. And you can subscribe to the platform event from anywhere. Like let it be your Apex, let it be your flows, let it be external systems, MuleSoft, doesn't really matter. Now what is important to notice when you're subscribing to these platform events, in this case I wrote a trigger. I wrote all my logic inside a trigger, not using a class, because it's easier to demo. So what's important is the trigger is being written on an object called data object data change event. So this is a standard event that is fired by data actions, irrespective of whatever data action it is. So this was for voltage drops. I might create some other data action for some other purpose. But still the platform event fired would be data object data change event. Now how do I know for which particular data action this was fired? I'll be able to filter that out based on the action developer name field. So this is the developer name field for the calculated insight that was the source of the data action. So I'm filtering based on that. And within that, there is a payload, which is going to be your actual data. And that data is again in a JSON format, so you'll have to deserialize it. Now the reason this is important is because this is easy in Apex. If you were listening to this platform event from a flow, you would still have to have an invocable method that actually converts this JSON payload into something that a flow can use. So it's not as simple as plugging the flow in. There is some amount of Apex involved. So again, key takeaway, one single type of event is fired, filter based on the action developer name, and then deserialize the data that you're getting back. After that, it is your own business logic. Here I'm creating a case, but you can do whatever you want with it. So yeah, this is typically some of the USPs that we wanted to show off Data Cloud. Like traditionally, people only talk about getting the data in, but not a lot of focus on what you can do with the data that is in your Data Cloud org. And we wanted to give you a peek on that. The most important thing being we are in TDX. We are talking a lot about AI. So Daniel mentioned that Data Cloud data can be used to train AI models. So let me hand it back to Daniel to show you how you can do that.
Thank you, Aditya. And I think I might have accidentally closed the tab for my Google Cloud. So just bear with me one moment while I get my Google Cloud back up. So here we are in Google Cloud. And I want to go to Vertex AI. Do we have anyone in here that's a data scientist? Yeah, okay, awesome. Anyone work with AI models, Jupyter Notebooks? Amazing. Python developers? Okay, a few of you. Okay, so Vertex AI is one of the integrations that Data Cloud can integrate with. Vertex is used to build large language models. It's used to build regression machine learning models. And I actually already have one of my machine learning models already set up here in Vertex AI. So I'm just going to go to the workbench. And I'm going to open up Jupyter Lab. And Jupyter Lab houses all of my notebooks in Vertex AI. And again, I apologize for the delay. I had this open earlier, but I guess I accidentally closed it out. So here we have our Vertex AI model. And what I wanted to show here is we are able to connect Vertex AI to Data Cloud. So what you'll first need to do is create a connected app. You're all developers, so I'm sure you've all worked with connected apps. So you need to create a connected app in Salesforce, and then afterwards you need to enable OAuth, and you need to select a few scopes, and then you're going to generate your client ID and secret. And what you're going to do is you're going to come into Google Cloud, and what you're going to do is you're going to store that client ID and secrets in Secret Manager, and then you're going to plug those into this notebook. Or at least for this example, I plugged it into this notebook. You don't necessarily have to plug into the notebook, but that is one way of connecting the notebook to Data Cloud. And then what you're going to have to do is you're going to have your Python connector set up here. So here we have our Data Cloud Python connector set up. And what's going to do is it's going to pass through all of your authorization credentials through that Python connector, okay? Then what that is going to enable you to do is to be able to query the data lake objects and the data model objects that are within your Data Cloud. So here I'm doing a simple SQL query to select a few fields from my data lake object. And what that's allowing me to do is use my Data Cloud data to train my AI models or machine learning models in Vertex AI. Now, I have some exploratory analysis that I can also do within the Jupyter Notebook on my Data Cloud data lake object. So this can show me some distribution, some statistics like my standard deviation, mean, median, mode, all of the things that data scientists love to do with data and love, like some type of bias reporting, all of that they love to do their exploratory analysis to make sure that the data they're pulling in is a good training set for their model. So then you can use this data to train your AI model, which we're doing in this very, very long notebook. This one is training our AI model with our Data Cloud data. And then at the end, what this notebook is doing is setting up our model endpoint right here. We're set up our model endpoint. So then we can call it via either Postman or to get an inference, or we can go to our new model builder within Einstein Studio, which allows us to connect external AI models that are using our data back into Data Cloud. So you'll use the Python connector, right, to use your data as a training data set in either Vertex AI or SageMaker or Databricks so that you can train your AI models with your data stored in either your data lake objects or your data model objects. So all of that is the training piece, right? Then what you'll do is you'll create an endpoint to actually call to create your predictions or your inferences. And here's where you set up the endpoint to be able to make your predictions. And then after you set up the endpoint, what you have the ability to do is create prediction jobs so that you can start making predictions in an automated fashion. You can keep feeding new data to your AI model that's already now been pre-trained with your data cloud data, and then feed it all of the inputs that you can keep making inferences or predictions on a regular basis that you define with your prediction jobs. All right? So it's kind of going full circle, and we have the ability to do this with SageMaker as well as Databricks. We currently already have some YouTube lives that we've done on SageMaker as well as some blog posts. I encourage you to go to our Salesforce Developers blog as well as our YouTube site to see how we did that. And I think we skipped through all here. And then here's the model builder slide. So what is available today is, again, the ability to connect your models in SageMaker, Vertex AI, and Databricks. We also, GA today, have the ability to bring in your large language models into Data Cloud as well. So you can pull in large language models that you built using OpenAI, Azure OpenAI. I'm sure you all know what OpenAI is because you guys are loving your chat GPT out there. So it integrates with OpenAI natively now via Model Builder. And we have a YouTube series out there. So everything that we've covered in today's presentation, well, almost everything that we've covered in today's presentation is available on our YouTube series. So if you scan this QR code, it will take you to our YouTube video series where we walk you through a lot of this stuff in depth. Some people have asked us some comments on YouTube, and we've also given some responses in the comments. So you may benefit from that as well.
We came a long way from just implementing Apex classes and Visualforce pages.
We have.
We are now in AI, Vertex, all of that. So
it's growing, and it's continuing to grow as well. So I've already seen the roadmaps, sandboxes, all of that amazing stuff, metadata support, VS Code support via the CLI. All of that is coming in the future. So we just want to say thank you. But before you leave, please, please, please scan this QR code and take the survey. Aditya and I actually do read all of the surveys that we receive. And one of the feedbacks from Dreamforce was they talked about the YouTube series, but they did not tell us where to go. And so we inserted a QR code for you guys to be able to scan for the YouTube series. So we do go through all of the comments, and we try to improve this talk based off of the comments and the feedback that you give us. I have some Salesforce developer stickers up here. If anybody wants some cool stickers, please take as many as you want on your way out. And I'll go back to the thank you.
Thank you, everyone.